Welcome to this video. We're going to be talking about arithmetic series. This is aligned with mathematics analysis and approaches, standard 1.2. So after studying sequences for a while, you might be thinking, what happens if we add the terms together? Take for example the sequence below, 1, 2, 3, 4, so on and so on, all the way to 100. What is 1 plus 2 plus 3 plus 4 plus sum, all the way to 100? In other words, what is the sum of all the numbers from 1 to 100? So Carl Friedrich Gauss was a really famous German mathematician who handled this very problem when he was in primary school. So the story goes that his teacher challenged him to find the sum of the numbers from 1 to 100, and to the teacher's amazement, he gave the correct answer almost immediately. So how did he do it? So here's the trick that he used. If we write out all the numbers in a particular way, 1 to 100, we can see that a pattern develops. So let's start with 1, 2, 3, 4, going all the way towards 50. We're going to stop and wrap it back around and then line up our numbers, 51, 52, so on, 97, 98, 99, 100. And if you add straight up and down, you'll see that you get 101, 2 plus 99 is also 101, 3 plus 98 is also 101, 101, so on and so on. You get the idea. All of the numbers lined up equal the same thing, 101. So how many of these are there? Well, I cut my total number, 100 numbers, in half, so I know there has to be 50. So there's 50 101s. 50 times 101 is 5050. So I know my sum must be 5050. So we can use the Gauss trick in general terms to actually define the formula for a mathematical series, which is the official term for the summation of all the terms of a sequence. So let's do the same thing. Let's write out our sequence. Starting with the first term, the second term plus, which we're going to add d, then the next term where we add d twice, so 2d, plus we wrap it around after we hit the halfway, and then here's our tail end, n minus 3, n minus 2, and then n minus 1 is the last term. And that's the formula we've learned before. Now, if we do the same thing, if we add straight up and down, we're going to get 2 u1s, and then we're going to get n minus 1d each time. So on the second one, you see 2 u1s, and then notice there's a positive d here and 2 negative d's. Together, that makes 1 negative d. And then same thing on this next one. 2 positive d's, 3 negative d's together make, again, negative 1d. So you get this same thing recurring over and over. But this part of it is actually just un. So we've really got u1 plus un. And again, how many times do we have it? Well, we wrapped it all the way around, half of our total terms, and our total terms being n, so we just divide it by 2. And so that's where we get this formula. N divided by 2 times the first term plus the last term. Alright, so let's try some examples. The first term of an arithmetic series is 5, and the last term is negative 51. The series has 15 terms. Find the common difference and the sum of the series. So we know that the first term is going to be 5, and the last term, which is actually just 15th term, is going to be negative 51. And I'm also going to write n equals 15. So remembering our formula for sequences, un is equal to u1 plus n minus 1 times d, we can find the common difference. So let's use u15 equals negative 51. So that'll be negative 51 equals u1, which is 5, plus n, this is a 15th term, minus 1 times d. We'll solve for d now. So subtract 5 on both sides, gives me negative 56 equals 15 minus 1 is 14, d. Negative divided by 14 on both sides, and we get negative 4 equals d. Now let's find the sum of the series, and we'll use the formula we just figured out. So we write s of n for sum, the number of terms divided by 2 times the first term plus the last term. So s of n, well, there's 15 terms, equals 15 divided by 2 times the first term, which is 5, plus the last term, which is negative 51. This is going to give us negative 345. Okay, in this problem we're told the first term of an arithmetic series is negative 7 and the fourth term is 23. We're also told the sum of the series is 689, and we're asked to find the number of terms in the series. Let's write out what we know. u1 is equal to negative 7, and u4 is equal to 23. We also know that the sum of n terms, because we don't know how many terms there are, equals 689. We're looking for n, and it will be helpful for us to also find d. So remember the formula in general for a series is for a sequence, equals u1 plus n minus 1 times d. Let's use u4 equals 23 to figure out what is d. So 23 is going to equal negative 7, because u1 is negative 7, plus n, well in this case n is 4, minus 1 times d. This is going to be 23 equals negative 7 plus 3d. Add 7 to both sides, gives you 30 equals 3d, which gives you d is equal to 10. Now let's use the sum formula to find what is n. So I'm going to make a quick change to the formula by substituting the value of un into the summation formula. So I get s of n equals n over 2 times 2u1, because there's a u1 in the sequence formula and in the sum formula, plus n minus 1 times d. Okay, now let's fill in what we know. I know s of n is 689, and then I've got n over 2 times u1, where u1 is negative 7, so that's negative 14, plus I don't know n, and then I know d is 10. Let's do some simplifying. Multiply by 2 on both sides gives you 1378 on the left, equals n times negative 14 plus 10n minus 10. Doing a little bit more quick simplification, we get 10n squared minus 14n, minus 28n, 24n, minus 1378. This is a quadratic equation which we can simplify using the quadratic formula or calculators by graphing and finding the points of intersection with the x-axis. If we do that and we factor it, we'll get the following. 2 times 5n plus 53 and n minus 13. So that means n can be two things. It can either be negative 53 over 5, or it can be 13. Now remember, in a sequence, each term has to be a whole number. You can't have the 53 over 5th term, so we know n has to be 13. In other words, there are 13 terms in this series. Okay, let's find the value of this summation from r equals 1 to 28 of 5r minus 4. So we can easily do this if we just figure out what is u1 and what is un. Well, in this case, u of 28. So if we plug in 1 to the expression, we get 5 times 1 minus 4. Well, that's just equal to 1. So I know u1 is going to equal 1. U of n, which in this case is actually 28, is going to equal 5 times 28 minus 4. 5 times 28 minus 4 is 136. So now that's going to equal 136. Now I just use my sum formula. There's 28 terms divided by 2 times the first term plus the last term. And that's going to give us a result of 1918. Alright, let's try one last question. The sum of an arithmetic series is given by s of n equals n times 2n minus 3. Find the common difference, d, and the first three terms of this series. So notice that this is not written exactly how we're used to, so we just need to manipulate it so it looks like what we're used to, and then we'll easily be able to tell what d is and then figure out the terms of the series. So let's remember the formula is s of n equals n divided by 2 times u1 plus un, which is equivalent to the other version of the same formula, 2u1 plus n minus 1 times d. Okay, we're given s of n equals n times 2n minus 3. I want to make it look like this one over here. So So first thing I'm going to do is rewrite it with n over 2 and actually double the terms on the inside. Now if I was to distribute the 2 again, I would just get back to here. So I know that those two things are equivalent. So I haven't done anything wrong. So I can see that the n minus 2 and the n divided by 2 match. So the insides must match. Let's rewrite this one in a different way. This is actually dn plus 2u1 minus d, if I was to distribute this and simplify. That has to equal the inside over here, 4n minus 6. So now I can see that 4n and dn match up, which means that d must be 4. And if d is 4, then 2u1 minus 4 has to equal negative 6, which means that u1 is equivalent to negative 1. So I've got u1, I got d, I found the common difference. Now let's find the first three terms. Well, u1 is equal to negative 1, so u2 would be equal to positive 3, and then u3 would be equal to positive 7. And that's it for this lesson. Now go and try some practice on your own.